It is good.
Haris, we are doing sequences. So far, we've done these first 14 questions. Do you remember how you used to solve these?
3, 6, 9.
Ali is trying question number 15. Can you join us there?
Just
So it
let me
will
know.
be, so 32.
How are you getting this, Ali?
Sir, it is 3, the difference of it. First is 3 and then 6 and then 9.
3, 6, 9.
9.
So
Then
you're
this will
taking
be
it to 12.
12.
Very good. 32. And then
And then 12, it will be 56.
why not 47?
Uh, oh, yes, I by mistake.
Question number 16. This is 1, 4, 20, and
दरवाजा
120.
बंद कर दो.
So what is the sequence going on?
1, 4, 15, 120.
In 16, 1,
First
4,
is
20, and 120.
it's 316. First is 3, then is 16, then is 100.
Okay, you're thinking about the differences. 1, 4, 20, 120. It's not always addition or subtraction, right?
Yes, sir. Yes.
So 1, 4, 20, and 120. So if I have to go from 1 to 4, either I was thinking it should be 1 square is 1, 2 square is 4, but then 3 square is 9, it is not 20. So this is not what we should be thinking. When we are thinking about the difference, this is 3, then 16, then 100. Still no pattern in 316 and 100. So there's nothing about this. Now see, what can I do to 1 to make it 4? If I just add 3, then again, we just went through that and add 16. I'm not getting any particular sequence. So what if I just multiply 1 with 4? I do get 4. And then 4 with 5, I get 20. And then with 6, I get 120. So this
Yes,
is
sir.
the sequence. Into 4, into 5, into 6. Next would be into 7. So 120 into 7 is 840. And then the next one would be into 8
Yes, sir.
is 6720. So 840 and 6720.
Yes, sir.
Haris, are you with us? Are you understanding this?
Yes, sir.
Okay. Now 17 again, some unusual sequence. 3140. It is increasing and decreasing. So what should be the sequence?
Um, it's 1, then it's 2, then 3. 1 minus 2 plus 3.
So this is plus
1
1, then
and
minus
minus
2.
2, and plus
This
3,
is plus 3,
then minus
then minus
3,
4.
4.
So if we continue the sequence 2, 3,
Yes, sir.
1,
1,
4, 0.
4,
First it is plus 1, minus 2.
minus
Plus
2.
3, minus 4.
Yes, sir. So it will be plus
Unknown
5.
and unknown. So
Plus 5.
basically, very good. When we look at the sequence 1, 3, this is 5. So
And that
0
will
plus
be
1 is 5,
minus 6.
minus 6. So this is minus 1. Haris, are you getting this? Is Haris with us?
Yes, sir.
Meanwhile, next sequence 720 and 120. If we divide these two, we get 6. And 120 divided by 6, I'm getting 20, not 24. So let's think different. Divide by 5 and then divide by 4. So then divide by 3 and divide by 2. Do you agree?
Yes, sir.
So dividing by 6, dividing by 5, 4, 3, and 2, we'll get our
Yes, sir.
next numbers. Finding the formula for nth term of a linear sequence. So there's this basic form. If we talk about the term number, let me represent it with t and n term number. So basic formula is n plus n minus 1 into d, where tn is equals to term number. T is the term, n represents the number. And a is always the first term of the sequence. D is the common difference. So we write D whenever we like. We also have to see if it is positive or negative. Now let's take an example. 6. This is one sequence. I can see that A is the first term, which is 6. N is the term number, and D is the difference, which is plus 2 in this case. So Tn could be A plus n minus 1 into d. Now a is the first term, that is 6, n is the term number, d is difference 2. Simplifying to get 2n plus 4. Now I'll see if this fits. So I'm selecting 1. I'm checking for t1. So 2 into 1 plus 4 is 2 plus 4 equals 6. So I do get that. Another attempt. T2 is 2n plus 4. So plugging in 2. 2 times is 4 plus 4 is 8. So yes, this formula is correct for 6, 8, 10, and 12. Now see if we have another formula: 100, 95, 90, 85, 80. So Tn is A plus n minus 1 into D, and this is for only for the linear sequence, which means adding a constant number or subtracting a constant number. So 100 plus n minus 1, and the difference is minus 5. So 100 minus 5n plus 5 simplifies it to 105 minus 5n. Now this is already done, but we do check it in exam with any random two numbers. Let's say I'm checking for third one. So 105 minus 5 into 3 is 105 minus 15, and I get 90. And let's say I'm checking with the fifth one. So 105 minus 5 into 5. So 105 minus 25, and we get 80. So for
What
the
if
linear
the
term, sorry,
different difference isn't common?
then we have different ways to solve it. We're currently doing for linear sequence. And when the sequence is not linear, if it is quadratic, we'll do it with different ways.
Okay.
So for question 1 to 16, find the formula for nth term of the sequence.
And and um,
Question number 1, what is the value of D?
3. Wait,
That's
no.
not 3,
4, 4, sorry.
4.
So yes.
So A plus n minus 1 into D. That will make it 5 minus 4 plus 4n. So this is 1 plus 4n. Now quickly check if it is correct. I'm plugging in 1. So 4 one time is 1 plus 1, 5. 4 one times 4 plus 1, 5. Now we plug in 2. 4 two times is 8. 8 plus 1 is 9. So this is correct. Try for this question number 3. Solve it and let me know what the formula is.
So it's 3n plus 6.
I think it's different. See, A plus N minus 1 into D. A is the
Sorry,
first
minus.
step.
I took plus 1.
Yeah, formula is minus 1. And the difference is plus 5 in this case. So
Yes, sir.
4 minus 5 plus 5n, and we get 5n minus 1.
Oh,
Look at question number 4. So we can clearly see the differences of plus 4. 6 plus 4, 10, 10 plus 4, 14, 14 plus 4 is 18. Let's change colors to avoid mixing. So A plus n minus 1 into D. A is 6. 6 plus n minus 1 into D. So 6 plus 4n minus 4. And it simplifies to 2 plus 4n.
yes, sir.
Try for question number 8.
Okay. What? P1 n minus 1. Get 1 into 1 n. So it will be 20 plus n.
That's right. This is 20 plus n. Now look at these fractions.
Yes, sir.
It is not necessary that we consider the complete number. First would be zero point 0.5, then 0.666, then 0.75, then 0.8. What we can do is we just look at the numerators 1, 2, 3, 4, and clearly I can see first term is 1, second is 2, third is 3, fourth is 4. So I can just write n.
Yes, sir.
And in the second one, these are again the difference is plus 1. So we can work that out. First term plus n minus 1 and difference is 1. So 2 plus n minus 1, n plus 1. So in the numerator, n plus 1. One way I use this formula. Second way could have been if I just ignore this and I see that the numerators is 1, 2, 3, 4. Starting from 1, it is exactly equal to the term number. So I can write n. And when I notice every term in the denominator is 1 more than the numerator, I can write n plus 1 directly.
Yes, sir.
Look at question number 12. 3, 4, 5, 6. So first term plus n minus 1 into difference. So 3 plus n minus 1. So I'm getting n
Uh,
plus 2.
n plus 2. Yes, sir.
In the numerator, n plus 2. Now notice that every denominator is 2
So,
less.
yes, sir. n
So
minus
we can
2.
write n.
N.
Or we could have just seen that it is 1, 2, 3, 4. Perfectly natural sequence number equal to term value. Try question
Yes,
number
sir.
16.
Question 16. -5.
What is the value of D?
Um, it's
Seven,
they're different.
Sorry, value of D?
So in the first is -4, and then it's
Ali, how is
-6,
it
and
-4?
that's how it's.
Observe that the values are increasing. D should be positive.
Oh yes, yes, yes. Three,
So D is,
four,
difference is +4.
4, yes, sir.
A
And it will be
n minus 1 into D.
yes, sir.
-5 plus 4 and -4, so it is 4n minus 9.
Yes, sir.
Question number 17. Write down each sequence and then find the nth term. So directly nth term. This is 2, 2, 2. So now let's quickly just write. First term is 8 and common difference is +2.
Yes,
For
sir.
B part, first term is 3 and the common difference is +4. For C part, first term is 8 and the common difference is +5. Try it for 18B.
Mm. Three, four. It's increasing by 2, so the whole number is increasing by 2.
The numbers are increasing by 2. So D is equals to +2 and
Plus
value
2.
of A is equals to 2 1 by 2 or 2.5.
Yes, yes, sir.
Haris, try C part.
C part.
Yeah. Value of A is -7. What is the value of D?
Uh, 3, seven, sorry, understand.
Haris, how do you find the difference? Look at the first number,
Yes, sir.
then the second number. Is it increasing or decreasing?
Decreasing, I think. Decreasing.
Increasing, Haris. Second number is -4. First is -7. Second
Oh,
number
okay,
is
the other
greater
one.
than the first
Not
one.
the B
So
one.
what do? We write the bigger number, subtract the smaller number. So you get +3. The numbers are increasing by +3.
Okay.
Here is a sequence of shapes made from pencil. Basically, nature of the question would stay same. There are different forms of representing it. Now we have this shape, sequence number 1, sequence 2, and sequence 3. If we count those pencils, we know in sequence 1 there are 4, then 7, and then 10. The number of pencil makes this sequence is 4, 7, 10, 13, and so on. Find an expression for nth term of the sequence. Now we're looking at 4 and 7. I see there's an increase of 3. 7 and 10 increase of 3. 10 and 13 increase of 3. So A plus n minus 1 into D. Where do we put this formula? Only when the sequence is linear. It is increasing by same number or decreasing by same number. So first term is 4, n minus 1, and the difference is 3. We simplify 4 plus 3n minus 3 and this gets 3n plus 1. B part
Yes.
says how many pencils are there in shape 1000. So we already know the formula Tn is equals to 3n plus 1. So if shape is 1000, so this is 3001 pencils in 1000th number.
Yes.
Ali, your question. What do we do if it is not constant? So that's known as quadratic sequence. Now in
Yes, sir.
quadratic sequence, you will observe this first one is the original sequence. So you see the difference was 2, then 4, then 6, then 8. And when you recheck that difference in the, this is known as first difference. Then this is the second difference, 2, 2, 2. When you have the same second difference, that is known as quadratic sequence.
Yes, sir.
Let's consider an example. If you see 9, 16, 25, 36. So I can see that 16 and 7, the difference is 9. Then 25 and 16, sorry, this was 7, this is 9. Then 36 and 27, 25, the difference is 11. So this is known as first difference. Now second difference in both of these is 2. So this is our quadratic sequence. In case we do not have common difference, in case we do not have this scene, then that is another form. We may do that with hit and trial. Okay. Now first we'll do what this book is telling us, and then I have another way also. So this is an square plus bn plus c. Now let me explain what these a, b, and c would mean here. So an square plus bn plus c. A is half of second difference. Like in this case, second difference was 2, so a would be equal to 1. C is zeroth term. Now going back again, this is first term, second term, third term, fourth term, fifth term. So how do I get the zeroth term? I will go back in reverse order to get this zeroth term. And how do we do that? See, 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2, so 2 minus 2 is 0. That's a coincidence that we're getting 0. We may get different values. Now, you see, 21 minus 8 was 13. 13 minus 6 was 7. 7 minus 4 is 3. 3 minus 2 is 1. So 1 minus 0 is 1. In this case, C is equals to 1. And how do we get B? When we are done with A, we are done with C, we will choose any one of these values. Let's say I choose this 3. So this is second term. What will I do? I will put 3 is equal to 2 into, I've chosen second term. 2 square plus b into 2 plus 1. So we already knew A, we already knew B, we've selected N ourselves. So B is the only one which can be solved. Okay, let's try question number 1. 4, 7, 12, and 19. Now the first difference is 3, then 5, and then 7. And let me quickly correct it. Where did I tell you that A was? Yeah, A was half of second difference, and I made this mistake. No, correct. A is 1. Half of second difference, A is 1. Everything's okay. I thought I just copied it. Okay, 4, 7, 12, and 19. So you see, this is not linear. This is 3, 5, 7.
Yes, sir.
And then the difference is 2 and 2. When
2
you
and
get
2.
second difference constant, we follow this. Tn is equals to an square plus bn plus c. Now a is half of second difference. So Tn is equals to 1n square plus bn plus c. And c is the zeroth term. To find the zeroth term, I'm getting back 2. So 3 minus 2 is 1. And 4 minus 1 is 3. So I get the value of c. Tn is equal to n square plus bn plus 3. Any objection till now?
No.
No, sir.
So we're done with A, we're done with C. To find B, select any of the given values, any one out of these. Choose any.
Third. 7.
Third.
7.
Okay, 7. That is
Second.
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 So 7 is equals to 2 square plus B into 2 plus 3. Now we can solve B only unknown. Is equals to 4 plus 3 is 7 already. So coincidence B is equals to 0. I'm writing the formula. En is equal to an square plus bn plus c. We knew a was 1, n square, b is 0, and c is 3. So I can write n square plus 3. Now check if this is correct. If I plug in 1, what do I get? The first term.
Uh,
If I plug in
um,
3, 9 plus 3 is 12. So I get
12.
the third term. So the
Yes,
formula
sir.
is correct.
Yes, sir.
Second. Question number 2 says 2, 8, 18, 32. 2 and 8. Difference is 6. 8 and 18. 10. 10 and 32. 32 and 18 is 14. First difference done. Second difference 4. 4. Now I'll be a little quick. En is equals to a n square plus bn plus c. A is half of second difference. So 2n square plus bn plus c. Now c is a zeroth term. So we're coming back 4. This is 2. 2 minus 2 is 0. So Tn is equals to 2n square plus Bn. Done. A done, C done. Now we select any of these values. Let's say I select this 32. The 32 is equals to 2, which is the fourth term. So 4 square plus B into 4. 4 times is 16. 16 2 times is 32. B is equals to 0. So basically C is 0, B is 0. So the final formula is 2n square. This is it. Question is complete. But what we do in exam, we always recheck. So 2n square, just put 1. What do you get?
Um,
If you plug in 1, what do you
1.
get?
12 square. 2.
2. And when you plug in 2, what do you get?
8.
8. With 3, what do you get?
12.
3 3 times is 9. 9 2 times is
Oh, yes,
8.
sir. 18.
So 2 8 18. 2 8 18. Check done.
Yes,
Yes,
sir.
this is correct.
Yes, sir. Okay.
One more. So you get used to it.
Good.
Select any.
Um, 11.
11. Okay.
2,
So this is 2, 9, 28, 65. Haris, are you with us? I can't hear
Yes,
you.
sir.
Haris, are you understanding?
Yes, sir.
Okay. So 2, 9, 28, and 65. I'm looking at the first difference, which is 7. Then 28 minus 9 difference is 19. Then 65 minus 28, the difference is 37. This is first difference. Now I'm checking for the second difference. 19 minus 7 is giving me 12. And 37 minus 19 is giving me
Uh,
18.
that's 18. Difference
Now
of
the difference is not constant. Find the nth formula of each sequence. Hmm, we'll do it some different way. 2, 9, 28, 65. 2 plus 7 is 9. 9 plus 19 is 28. Plus 37 is 65. It shouldn't be here. This is not quadratic. 2, 9, 28, 65. Yeah, no, clearly no. Second difference is not constant.
yes, sir.
Let's take a different example. 3, 9, 27, 81. I'll look into this. Difference is 6. And 27 minus 9 difference is 18. Oh no. This is 3 raised to power something, clearly. 3 3 is a 9, 9 3 is 27, and so on. So 3 raised to power n. Clear? This 15th.
Yes, sir.
So to go through these questions, try them. The more you practice, you'll be able to analyze the question and see which sequence is actually occurring at that point. Okay.
Okay, sir.
Exercise 1.4C. And this one was pretty easy. 1.4B. So 1.4C only.
Yes,
And
sir.
inshallah, we'll discuss any problems tomorrow.
Oh,
Take care.
love you,
Yes,
sir.
sir. Allah Hafiz.